Lab 4 was about oscillations. The purpose of Lab 4 was to observe a spring mass's motion in Tracker and predict the same spring mass's motion in VPython using Newton's second law, the energy model as it pertains to spring and mass systems. And then the final step was to compare the results. So working in Tracker, I used the video given on WebAssign, I believe it was, or using the EDX software. And I tracked the motion of the spring. I got the following graph here of the masses, or the spring masses motion, and then the following x and y coordinates. I then went ahead and found the spring constant k. Although in the lab videos it was calculated for us, I wanted to make sure that the values that I calculated using Tracker were the same. Turns out they were not, although they were very similar. The K value that I got was 6.87 Newton meters. And then I went ahead and calculated the relaxed length, L sub 0, using the following formula, and I got L sub 0 to equal 0.126 meters. So again, this was very close to what was calculated previously in the video, but it was not the same. I plugged in those values into my VPython code, and I got the following predictions versus observations. So as you can see, this is the model position, the predicted position, if you will, and then the observed position, or my observed data, is this really jagged red line. I was quite surprised to see this, but I do attribute that to tracking once again in Tracker. It's not entirely accurate, and I'm not apparently very good at it. And then also the time step in the code might have altered the way that this was perceived as well. So looking at the model position, I put in the correct formulas, it would seem, as I got the following graph. Got the total energy to be 0, which I will discuss in the next slide. But here's a video again showing the differentiation in my predicted and my observed models. So as you can see, the observed model is doing a lot of bouncing around, and the predicted model is quite smooth. Again, I attribute this to the time step. So as for my model system, I believe the energy model was satisfied. Why is that? Firstly, there was no movement of the spring from its attachment point in the video, and eventually the work done by forces acting on the spring and mass system was equal to the change in kinetic energy of the system. Another way to tell this is because you have all the different changes in energy here, and then finally you have that the total energy of the system is 0. It's a straight line at 0 on the graph, and that it further confirms that my hypotheses of the model system satisfying the energy model was correct.